Hello everyone. In this video, we will see some programs related to prime factorization. Okay, so these will be basic program, guys. But I need to talk to you about prime numbers and prime factorizations. Okay, so the people who are not, like me, who are not from English background, who didn't study in English medium school or college. So English terms make us confused, guys. Yeah. So I don't know about you guys, but uh, it happens with me a lot. Okay, so this is why I try to explain everything, with a relatable way, right? Okay, so let's see which programs of prime numbers we did before, right? So maybe before 15 or maybe more than 15 days, we did some prime number related programs, right? So you see here, I hope you already know what prime number is. Okay, so the example what I always refer to people, that if you have 5 mangoes and if you want to divide these mangoes among some boys. Okay, so any number of boys, let's 2 3 4. Okay, so without cutting the mangoes, you can't divide these mangoes to any number of boys. Okay, so except 5 and 1. If you take 5 boys, you can give the one mango each. Okay, so if you take one boy, you can give all the mangoes, all the 5 mangoes, to this boy. So 1 and 5 shouldn't be considered, right? So except these numbers, you can't take any number who can divide 5, right? Evenly divide 5. So this is prime number, guys. Okay, so these are the programs we saw about the prime numbers. Okay, so prime number checker, we took input from the user, and whatever the number user gives us, we check if the number is prime or not, right? And prime number generator. Okay, so we give a limit, uh, like uh, if user provides 20, so we see how many prime numbers are between 2 and 20, right? So uh, so this was the program here. So, and largest prime factor, so this was the program, whatever number user provides, like 26 or whatever. Okay, so we saw, I mean, this program ensures which number is the largest prime number to divide 26. Okay, so this would be 13, guys. Okay, we know 13 is a prime number, and if we divide 26 by 13, we get 2. So 13 is the largest prime factor which can divide 26. Okay, uh, okay, and then twin prime checker, we saw twin prime checker, guys. And twin primes are primes that are that if you take two prime numbers, okay, and if they have difference of 2, like 5 and 7. Okay, the 3 and 5, so these are twin prime numbers. So we saw this program as well, and we will revise them, of course, after finishing these prime factorization videos. But we're just checking out what we actually learned. Okay, sum of primes, you already know what it is, and Goldbach's conjecture, right? So what was Goldbach's conjecture? Do you remember? Uh, any even number greater than 2, right? 6, 8, whatever number you take. So you will see you can get this number uh, by adding some prime numbers, right? Let's say you take 6, and uh, you can get 1, 2, and 3 to if you add them, you get 6, right? So these were the programs we saw, guys, and today we will see prime factorization programs. Okay, so if you take any number like 12, 15, whatever number you take, and we see which prime numbers divides them. Okay, so if you take 12, so 2 divides 12, so 2 is a prime factor, right? So 3 is a prime factor. 3 also divides 12, but 4 can also divide 12, but 4 is not a prime number, so 4 will not be considered in this case, right? So we are dealing with the prime factorization. Okay, that means uh, we will deal with the numbers, with this kind of numbers, that numbers are divided by the prime numbers, and we will consider only these prime factors only. Okay, so our first program is find prime factors of a number, right? So if you take any number like 12 or whatever, so we will take only the prime factors, okay, not non-prime factors like 4 and 6. 4 and 6 also can divide 12, but we are not considering 4 and 6 in this case. We will just consider uh, 4 and 2, 3. So this kind of prime factors, right? So let's see how it actually works, right? You can see the program here, guys, in my screen, right? And we are taking a number as input from the user, right? So you already know these things. And find prime factors, so this is the function we need to go now, and everything will be uh, everything will be performed in this function. Okay, so we are going in this find prime factors function. Okay, so beginning of this is prime factors of these numbers are. Okay, so what if you provide 12, so you know this will take 12. So now we have loops. Okay, so what does this loop do? Divide by 2 until n becomes odd. Okay, so we have to, if you so when we take a number, so we how we find the factor of it. Okay, so we start dividing by 2, okay, and then 3 and then 4. So this is how we continuously divide. Okay, so to minimize it, we divide this number, right? So if you see here, we can divide 12 by 2. We can start by 2. Okay, so we get 6, and that 6 also can divide by 2. Okay, so we get 3, and this is the 3. Okay, so we can divide 3 by 3. So all of these numbers are prime factors. Okay, so let's see how this program works, guys. Okay, so we find prime factors is this is the function here. This is this function, right? We are coming in this function, and now we have a while loop, right? So uh, so we are in this while loop. If you see here, uh, we have uh, 12 as an argument, right? So in the first iteration, 12 modulus 2 equals 0. It's true. Then we print 2, right? And then a space. We print 2 and then a space. If we get, if it's divided by 2, then we print 2 first. Okay, so we will discuss why we need to print it. So now n is divided by 2, and it's stored in the n as well. Okay, so in this line, you see, in this line, what this is the line actually. So this line you can write in this way as well, n equals n divided by 2, right? So if you divide 12 by 2, you will get 6. So this is what happens here. This is what you know this is what we wrote here, right? So we get 6, right? So this would be our second iteration. In the second iteration, 6 modulus 2 equals 0, so it's 2. Then we print 2 again, right? And then a space. Okay, so let's just run this program, then you can understand. If you run this program, you get 12. So prime factors of 12 are 2, 2, 3, right? So in the first iteration, we printed these 2 and a space and then the 2, right? So this is why we put we put a space in the here, right? So second iteration, 6 divided by 2, we get 3. Okay, so this will be our third iteration, guys. Third iteration, right? So 3 modulus 2 is condition is false, right? So we cannot enter into the loop, so we can just erase them. Okay, so now we will terminate from this loop. Okay, we will terminate from this while loop, and then we will come out of this loop. Okay, so now we have another for loop. So this, what does this for loop do, guys? This for loop check for odd prime factors, right? So I starts from I starts from 3, and I into I equal to or less than n, right? So let's visualize this one. What do you think, what will happen here? Just pause the video and guess, right? So for the first iteration, I starts from 3, and I into I, that means 3 into 3. Okay, so less than equal to 10. 3 into 3 is 9. Okay, so we after while we finished when we finished third iteration in while loop, we had only 3, right? So 3 into 3 is 9, so it go beyond the limit, our limit. Okay, so our n is only 3 here. Okay, so I start from 3, and I into I, 3 into 3 equals 9, right? So if it's less than n, so our n is 3, so 9 is not less than or less than 3, so we cannot enter into this for loop, guys. Okay, so now we will jump. I mean, we can't enter into this for loop. Then we have if statement. Okay, so if n greater than 2, okay, so n is greater than 2, of course, because our n is 3, so 3 is greater than 2, so n will be printed, so 3 will be printed. Okay, so now we are printing a new line. I hope you understand how we got 2, 2 and 3, right? So uh, this is how we get the prime factors of a number, right? Our second program is we will check if a number is a prime power. So what is prime power, guys? We need to understand. Okay, so first of all, you see in my screen, we are providing 2 as a power in 2. Okay, so 2 is 2 to the power 2, right? 2 to the power 2, so it gives us 4. So 2 is a prime number, these two, the base, not the power. The base is prime base, right? So after giving a power to a prime base, we are getting 4. So this 4 is a prime power. Okay, so if you increase the power on 2, 2 to the power 3, 8, 8 is a prime power. So if you provide 4 here, we will get 16. 16 is a prime power. Okay, so let's say 10. So you cannot give a power to 2 and get 10. No. Okay, so which number you will provide here? Okay, so if you provide 2 as a power of 2 in 2, 2 to the power 2 makes 4, 2 to the power 3 makes 8, 2 to the power 4 makes 16. So we don't get 10 in this way. If you provide you know uh, any power on 3, you can't get 10. Okay, so 10 is not a prime power. 3 is a prime number. So let's see uh, which prime numbers, which prime powers we get uh, doing so. So 3 square equals 9. 9 is a prime power. 3 cube 27 is a prime power. 3 to the power 4, 81 is a prime power. So these are prime powers. Okay, so if you provide like 5 to the power 1 is a prime power. 5 to the 5 square, 24. Okay, so 25 is a prime power. 5 cubed at 125. So these are prime powers. Okay, these numbers are prime power. If you take any random number like 50, 50 may not be a prime power. We have to understand which are prime powers. Okay, so in this program, let's see how actually this program works, right? So there's a condition, guys. First of all, whatever base we take, this base have to be has to be prime number first. Okay, then we need to check which power makes gives us that number, which number we want to check. Okay, that's 16. Okay, so first of all we have to let's say 16, we have to take, first of all we have to take a prime base 2, 3, whatever, and we will try to give a power so that we get that number like 16, 25, whatever it is. Okay, so you see the program in my screen here. Okay, so now you already know what this function does, is prime. So is prime gives us if is prime checks if any number is prime, right? Any number is a prime number, so we need this function to check if it's a prime number. Then okay, let's start from here. Main function. So the program already always starts from main function, we already know. Okay, so number, enter a number, so we will take the input from here, and if is prime power number, so if it's true, so we have to go to the is prime power, right? We are coming in the is prime power, so we will visualize from here, right? Let's go to the our this page. Okay, each prime power we are providing 16, like, okay, we are providing 16 as an argument. Okay, so we have a for loop, and in this first iteration is in this first iteration, p starts from 2. Okay, so this is because prime number starts from 2, and we divide every number with 2, right, to check if it's a prime number or whatever. So prime p starts from 2, and p equals less than or equal to square root of n. So we already know that if you want to check a number, then we don't have to go beyond square root of it. Okay, so like if you want to provide check 16, then uh, iterate to 6 is enough. So we already discussed about these things, but uh, you can check my previous videos, prime number videos. Okay, anyway, uh, okay, so in our case it should be 4, right? So we don't need to go beyond 4 times. Okay, so is prime p, is prime p, you see here, is prime p, that means whatever p is, p will come here. Okay, so is prime p means 2. So now we will go to the is prime function, and you already know how this is prime function works. Okay, so if you don't know, you need to you need to try to visualize this one. So after visualizing, we will get 2 is a prime number, right? So do you want me to explain this to you? Okay, I'm going to explain this to you. If n less than or equal to 1, okay, so return 0. That means if n is less than or equal to 1, or 0, then it's not a prime number. 1 is not a prime number. So now we will check. Integer I starts from 2, and I into I less than or equal to n. Okay, so uh, that means uh, let's say you want to check any number 16. Okay, so you don't have to uh, go to the more than uh, that number, right? So I into I, if square of it makes that number. Okay, so let's say I'm going to break it down for you guys. It will take some time. I wanted to save some time. Okay, so let's say you want to get 36. So how many ways we can get 36? So these are the ways we can get 36, guys. Okay, 2 into 18, 3 into 12, 4 into 9, 6 into 6, right? So if you see all of the numbers, okay, uh, this side 2, 3, 4, these are the numbers less than 6. Okay, and these are the numbers 18, 12, 9, these are the number more than 6. So we don't need to go to 18 or 12. Okay, so we don't need to divide 36 by 18 or 12 to check if if 36 is prime, because if we can divide by 2, we can say that this is not a prime number. If we can divide by 3, we can say that this is not a prime number. Okay, if it's evenly divided, it's not a prime number. So uh, iterating up to 6 is enough. Okay, so do you understand? If we can divide by these, so we can decide that this is not a prime number. We don't need to go beyond it 6. We don't need to go to 9, 12, 18. No, if we can divide by 4, then it will be divided by 9 as well. It's fine, finished here. So if you see here, I equals to I starts from 2, and I into I. Okay, so that means 2 into 2. Okay, and less than or equal to n. So our n is 2, guys. Okay, our n is 2. So it so 2, 2 into 2, 4. Okay, so our this condition becomes false, guys, and we come in, we jump from this for loop, we don't enter into this loop, and return 1. So in case of 2, we can prove that 2 is a prime, right? So here we have to come here, is prime 2, right? Is prime 2, integer power equal to p. power gets the value of p. So value of p is 2, right? So if you see here, power gets the value of t. So now we have a while loop, first iteration. You see here, first iteration, p less than or equal to n. Okay, power less than or equal to n. So power was 2, right? Power holds the value of p. So power was 2. 2 is less than or equal to n. So our n is 16 here, right? So it is true. So power into power equal to power into p. So we can write this line in this way as well. Power equals to power into 2, right? In this case, that means you can say p. Okay. So if you see here, so it becomes 4, guys. Okay. So if power equals n, then we will return 1. Okay. So what does this actually mean, guys? In this case, if this power, if this 2 into 2 makes our, if would make 16, then it would be a prime power according to our condition, right? So we don't get this, we get only 4, right? So this is not true. Is not, power is not equals n, that means not 16. So this would be false, guys. So this power increases here, right? 4. So now we will get second iteration. 4 is less than or equal to n. So n is 16, I wrote here, okay, for your convenience. So 4 is less than or equal to 6. Okay, so power equals power into 2. Okay, so this is for what, guys? If you see here, power into p. Okay, so p is 2 in this case. P is 2 in this case, right? Always 2 will be in consideration. So 4 into 2, 8. So this is not, this condition will again be false, right? And then third iteration, while power 8, so 8 is here, we got 8 as a power. So 8 is less than or equal to 16 is true. Then 8 into 2 is 8, 16, not 18, it's 16. So we got power equals n. Okay, so power is 16, n is also 16. So now we will return 1. That means it's a power prime. It's true, right? So where we came where for from where we came here, guys, is prime power. Okay, so from where we came here from the main function, right? Here, so is prime power 1. Okay, so this whole function is giving us true. That means 1, it's prime power. So now we'll print is a prime power. Okay, so if it was not, then we would print it's not a prime power, right? So let's say here, if you provide 16, it says a prime power, and if you provide 12, is not a prime power. So this is what we saw, guys. So I hope you understood this program and you liked it. So uh, if this video helps you to learn programming, please like my video, guys, and keep supporting me. I will make videos step by step, and I will build a channel in which people will truly understand programming and truly love programming. And there, you don't have to give anywhere, you don't have to go anywhere to learn programming anywhere else, right? Thank you for watching, guys. See you in the next video.